In this problem, we're looking for the maximum volume, and we're looking for a box right here in the XYZ plane. And we know that it's going to be touching this equation here. So this is our constraint that we'll use for our Lagrange. And we're going to go ahead and build that over here, XYZ, with our lambda. That's going to be equal to XYZ minus, x squared over 9 plus y squared over 25 plus z squared over 64 minus 1. And it's supposed to be, I guess, equal to 0 and stuff. Then we'll go ahead and take our partial in terms of x. So that's just going to be yz minus 2 lambda x over 9 equals 0. And then that one's going to be for y. Okay, so xz minus 2 lambda, and then we would have a y over 25. And that's equal to 0. And then we'll go ahead and do the z one, which is going to be xy minus 2z lambda over 64. That's supposed to be equal to 0. So we're going to rearrange these equations and say yz equals 2 lambda x over 9, and then xz equals 2y lambda over 25, and then xy is equal to z lambda over 64. So then we can start dividing these things and getting rid of some variables. So we'll go, this divided by that is going to be y over x equals, well, we're going to get rid of the 2's, but we're going to be left with, like, well, it's kind of like as if we multiplied 25 on top, and then we have 9 on the bottom. So we'll get 25, 9, and then we'll have x over y. Okay. And then we can go ahead and do that same thing over here. We'll divide this top by this one by that one, and we'll say that z over y is equal to, this should be similarly to what we did over here. I should say 64 over 25, and then y over z. Okay, and then once we sort of rearrange these equations, we'll be able to see that 9y squared equals 25x squared, and 25z squared equals 64y squared. From here, we should try to solve for y squared, 25 over 9x squared, and then we'll plug that in over here, and we'll say 25z squared equals 64. We got the y squared is 24 over 9x squared. So we'll even divide this by 25 so we can solve for z. So that'll be like z squared equals 64 over 9x squared. And from here, we've got a lot of information, and we can plug it back into this. So we can say that x squared over 9 plus y squared over 25. Well, let's just divide this thing by 25, and we'll have x squared over 9. And then we'll have plus z squared over that. So I guess we'll divide this by 64, and we'll have x squared over 9. And then when that's supposed to equal 1. That means that 3x squared over 9 equals 1. And so we kind of find that x equals plus or minus the square root of 3. Now, it is supposed to be volume, and we're in the positive, so we have to have this be the positive version. So it's x squared is 3. And now we can try plugging that back into our equations over here. So we'll say that y squared is equal to basically 25 over 9 times 3. And so we could say 25 over 9 times 3. But then we have to square root that. So y is going to be equal to 5 squared root 3 over 3. And then when we solve for z, we'll go ahead and just square root that. So 64 over 9 times 3, and then we have 2 square root that. So it's just going to be z is 8 square root of 3 over 3. And now we found that at this coordinate point we have some kind of maximum happening because we set the derivative equal to 0. So that works.